And the goal here is to develop characterization tools that will allow us to characterize these thin film materials. They're much more difficult to characterize than wafer silicon for several reasons. One of the biggest reasons is that the surface and the surface recombination for as-grown wafers is much more of a dominating factor in carrier lifetime than for wafer material. It plays a bigger role because the surface recombinations affect very adversely as the thickness of the wafer. So as the wafer gets thinner, the surface is a bigger problem. Okay, I'm going to start out with our lifetime measurement techniques. We have three techniques that we predominantly use for silicon materials, non-3-5 materials. These are the resonant coupled photoconductive decay, which was invented at NREL, and we have a station over there. We have a station here at the Colorado School of Mines. Microwave reflection, which has been a standard technique invented many years ago in Germany, and microwave reflection is the basis of the semi-lab mapper. That's a commercial instrument widely used today. And then finally, transmission modulated PCD, which was invented here at the School of Mines early this year. It's the subject of a patent, and it has some attributes that both of the other two techniques do not have. So we use all three techniques, hoping to gain information, the best information from all of them. So again, this is kind of new territory. These materials of this type have not been amenable to this kind of lifetime test. There are other techniques that have been used, like time of flight, but not measurement of lifetime directly. And we have several techniques here that give us information about these materials. But this is in a formative stage, and it'll take more work to figure out what's really going on with these materials. The interesting thing is we see signals with all three techniques, and they're all different. And contained in that difference is a lot of information about the mechanisms, the transfer mechanisms within the samples. So in summary, what we've done during this time period is we've correlated the electronic and structural properties of the silicon epi thin films. And this showed how the structural properties and the defects in the structure showed up quite strongly in the electronic properties of recombination behaviors. We explored new recombination lifetime techniques for various thin film and low dimensional structures. So we have the nanocrystalline silicon, we have the 326 wires, we've a number of other low dimensional structures that are amenable to this technique. That is, that we can measure carrier lifetime by these techniques that are difficult to do by any conventional techniques. So we began studies of these two-dimensional structures, and finally we're training two promising young PhD students to work in this field, and hopefully will continue to make contributions and go out in the industry and do great things.